Okay, welcome to another Sunday programming stream where I will be attempting to make a game of Snake in Python. Relatively, well, simple-ish Python, kind of GCSE type level Python. I'm going to be using processing in the shape of P5, and I'm going to be doing it all in the Raspberry Pi code editor. But let's talk about Snake. Snake, as it turns out, is not just a game. It is a whole genre of game, and I associate it mostly with the 1998 Nokia Snake game, which is what I clearly grew up. What was the window not sharing? Whoa. Okay. Yes. And yes. Okay. Well, Snake is a whole video game genre, as we've seen. I am of the generation where my first mobile phone had Snake. That was a Nokia. This is a classic. This is how we spent time back in the day. But it turns out that it originates from the 1970s, an arcade two-player game called Blockade. There was also a tie-in game of Tron with the original 80s movie with the light cycles, and you kind of two-player and you kind of block the other player. The principle is very much the same. So I'm doing this in the Raspberry Pi code editor that you can find by simply searching for Raspberry Pi code editor, right? If I could spell it, which takes you straight there. The beauty of it is I'm going to log in just so I don't lose my stuff, but I keep looking here because I've got two screens now. Okay, I'm going to log in real quick, but you can you start coding Python, and boom, you're starting coding Python. Well, I say that. Ah, well, it looks like everything is working today, so I expect it's going to be a good one. Let me just put a quick timer so I know where I am. And boop, boop, boop. Right, okay, I'm logging in. And Snake, without further ado. Okay, Snakes, if you want to see what it's, I forgot. If you want to see what it looks like, that's probably the younger generation might know it as this one. You go to search for Google Snake. I can't believe they have a daily challenge. Like there's some kind of hardcore leaderboards of the Snake community. Oh, wow. Okay. Wow, moving apples. Right. No, that's not the original Snake. Let me just demo the game as it. Oh, and leaves this is okay. This is crazy Snake plus plus. But, right, the classic Snake, just not the daily challenge, just the regular Snake. Play. Play. Right. Okay. Regular snakes like this, as you eat apples or eggs or whatever, as you eat little things that are randomly put onto the grid. You notice it's a grid, right? The snake is moving, but there's a checkerboard pattern. And I can't turn closer than this. It does some little noises as well, which is cute, right? And every time you eat the thing, the snakes gets longer, making the game trickier and trickier, as mainly you need to avoid, well, yourself and the walls, admittedly. I think I'm going to make an easy snake that wraps around where you can, well, I mean, you can, we can worry about that in a minute. Let's see if the code editor has come back. Okay, cool. That's my code editor. Remember to name your stuff blank. Well, again. Oh, you just click the thing. Okay, so I'm going snake. Right. It's a P5 project, so let me just make that bigger and hide this so I can afford to make the text bigger. So it's actually, we're going to do from P5 import star. This gives me all of the functions in the package, and I'm going to need from random import rendint. In that order because it's alphabetical, but there's a case for having the specific, whatever. Okay, Snake. No, wait, let's just do the skeleton of P5. P5 is a Python port of Processing 5, which you can also find straight up online at p5js.org, I think. Whatever. P5 Python reference. It's a bit of a hobbyist sport, so they're not kind of they're not as much on top as the original processing within Java. Processing is a framework it's ostensibly for artists, but you can make kind of visual, kind of arty graphics essentially and an interaction relatively easily. So in a way, it's if it weren't for its performance, essentially it would be a good framework for games, and definitely for those kind of little games, it works. What we need for processing, works with two core functions. One is called setup. This is the function that will run once at the very beginning of the sketch. This is how we call a processing program, a sketch, to set up. I'm already disliking the 4-tab indent, but that's Raspberry Pi Code Editor. Raspberry Pi Code Editor does P5 straight out of your browser with caveats we'll discover in a second. And draw is the function that will be called every frame. Normally, a processing sketch that runs in processing only needs that, but when you import P5 and run it into Python, you need to run processing with run. In that instance, well, I'll see about the frame rate in a second. Okay, right. This is the start of the beginning. Snake, as we have seen, the snake has a head. There's a direction. The head moves along the direction. Player controls change the direction. So in a way, although this snake, right, is played with 4 keys, one of them will go forward and do nothing, and you can never go backward. So really, you only need 2 keys, and if you play with 4 keys on this one, you're gonna be using 2 different keys every time. So on the Nokia, there are 2 types of players. There was the one that using kind of the middle and use a cross, and those that would just only use 2 buttons and do it relative to the snake. We are going to do something quite different because of the limitation of P5 inside the Raspberry Pi Code Editor. But again, such is the price of, you don't want to have to kind of like install packages and set up your Python environment. And in fact, it's because I'm struggling with this at the moment on the Mac that I'm not running it natively. I realize my Mac is kind of now 10 years old, so I think the Intel architecture is barely supported. Whatever. Okay, the player control change the direction. There's a random apple spawned, well, an apple spawns randomly. Eating / hitting the apple lengthens the snake, and then the tail, right? The tail move following the snake, hitting the head, hitting the tail. And then I've got some kind of further extension, maybe some score, and then high score. Yeah, score, high score, etc. Okay, so that's just so I know where I'm going and I don't lose track because the afternoon dose of the ADHD med hasn't kicked in yet. Keep track of the score. I don't know if we're going to be able to do a high score because again I've got a little problem with the limitations of P5 running in the Raspberry Pi Code Editor, which TLOP clop RE so the topic. Okay, the head. I've got a head. So the head, fair enough. Just going to call a variable called head. I'm going to use a list. I could use a tuple. There's pros and cons. Whatever. Let's start the head in the middle and 200. The direction. Let's start the direction as east. E for east, I'm going to use 1-letter character codes. The head moves along the direction. Def move. Pass for a second. Let me just do the setup. The setup, we want a background. No, actually, we want a sketch of size 400 by 400. You can make that a variable, but then you may need to scale a whole bunch of other variables, but fine that, whatever. Background, I'm going to use like words. It supports 0 would be black, 000 would be black because it's red, green, blue, black, or black would be black, or hashtag 00000 is also black. That's called polymorphism, and because this is a GCSE tutorial, you don't need to know what this means. And the head, we're going to spawn the apple. I'm just getting ahead of myself there. When we set up, but I'm going to comment to that because we don't have it yet. When we draw, we want to move. That's the first thing we do, and also we're going to have a draw snake method. Okay, so move. The snake moves on its own, right? It's just depending on the direction, we're going to change one of the coordinates, one of the elements, indices of head, of the head variable. So if direction, spelling it right, direction is equal to E, then, so if I'm moving east, I want the head to become equal to a list made of head east, which is good. Well, yeah, right, fair enough, right? So like X increases. You know what? I'm going to use a tuple. No, I'm going to use a list and I'm going to change it to a tuple and I'm going to explain why it's more powerful to use a tuple. Now, this is where we're venturing into kind of A level, or maybe to a degree not even on the A level spec type knowledge, but that's a good opportunity to show it. So, if we're moving east, forgive me, the first coordinate, the X coordinate of the head increases because we're moving to the right of the screen. Whereas the second coordinate, Y, doesn't change. And then elif, let's do it, actually L, poof. There's going to be a lot of copying and pasting, the software's developer's secret weapon, before Stack Overflow, and even ChatGPT, because you need to copy and paste from somewhere, but like copying and paste from your own thing. Whereas if the direction is, let's go anti-clockwise this time for some reason. So if it's north, the X doesn't change, but the head one is -1. I could have changed just this. Actually, I can do this because head is a list, but I think this makes it clearer to see what changes, what doesn't. Now I've got this, which is brilliant because they've got both the vertical and the horizontal. So I can do L if direction is northwest. So in west, now we decrease the X. And if we are going south, we increase the Y. In processing, right, the X, Y, the X is left to right, as you'd expect. The Y is actually top to bottom. Think of an Excel spreadsheet, or, it's not kind of maths coordinate. The Y goes down. The right starts in the top. So 0, 0 is here. 200, 200 is here, and hopefully 400, 400 is in that corner. Right, we've got the move. Cool. The player, let's see if we might want to actually draw the head. So let's do a quick draw snake. Okay, def draw snake. I will want, I'm going to want a variable size because, okay, we could make the snake 1 pixel wide and the apple 1 pixel, but that's going to require a lot of precision and it's going to make this going to be a huge kind of level. It's going to be really tricky. Either you're moving fast to kind of compensate for the huge level, but then you got to be very precise to catch the apples, whatever. So size, I'm going to have a snake that's made out of 10 pixel blocks. It's called snake, but it's really a worm because effectively we get separate segments, as we'll see in a second. So size equal 10. This is like the size of the snake, right? I think that's pretty self-explanatory. Okay, the player control. Let's do the draw snake. We're doing the draw snake, right? So in setup, I'm also going to want to say stroke underscore weight. That's the thickness of the pen, so that affects curves and outlines of shapes, etc. And that's going to be size, right? So that decides how thick the snake is drawn. Fair enough, right? To draw the snake, I will draw the head, which at the moment this is all we have, but we're going to have the tail, right? This is the tail is the tricky part of the snake, but the tail is most of the snake. To draw the head, we are going to select stroke. So just stroke, as opposed to stroke weight, gives you a color. Here again, I'm using text. That's going to be green. And we are going to do point at coordinates head 0, head 1. You wish there was polymorphism that you could pass the list of 2 elements. Maybe if I do a tuple, it will work. But yeah, that draws the snake. So does have background black, stroke weight respond, the apple which no, we get move and we get draw snake. All right, does that work? Doesn't. Because head is referenced before assignment at line 20. That is because, yes, okay, so this is, yeah, another important thing is scope. So that's kind of vaguely GCSE-ish at the edge of GCSE in year 12. Scope means how far do we look around when we're talking about names? There's a fancy IT CS word for names. but I've forgotten about it. So like the name of a variable, indicators, informators. Sorry. Okay. Right. So this has got access to. This is inside a function, and it's got access to everything. If I define a variable here, anything outside of this function doesn't have access to it. In fact, once the function has run, the variable will disappear. It will be garbage collected. Um, so here I'm defining something, right? So, but that's defining a head and changing head that makes it kind of local. So what we want, direction, we can read any variables in the higher scope. So anything that calls that function, the function that's being called is going to have access to head and direction. But it's got access to those read only. If I want to change it, what it's doing here is it's creating a new head variable that's local to this function. If I want to change a variable into into a local scope, I need to define it as a global variable, but only the ones I want to change. So here, global head, for the control of the direction, I will have a global direction because that's the thing we're changing. Look at that. Okay, so green, that's a little bit, is this popping enough? Yeah, I might, you know what, I'm just going to make it like really flashy green. So that kind of green. Yeah, okay, so that's moving. Well, the snake is moving. We're very happy with this. What I'm going to do as well is that it's not +1, actually, or -1. This has to be Control D or Command D will select any other instance. This is plus size because we want to move in increment of size. So again, if I select this and you do Control D or Apple D, it selects all of the instances of the thing at the same time. So now you can edit. It's brilliant. And this is coming from, this is a shortcut from professional IDEs, which are used more and more in school now. But it's nice of the Raspberry Pi Foundation to have put in their IDE online code editor. So now it's going to move much faster, right? Because now we see the individual dots. But really, it's on a grid, so it's important that kind of we move in dots. So because it's moving fast, or we're going to say, because that's one every frame, right? So like every frame, there's like 30 frames a second. Before we know it, there's like 20 dots to the edge, right? Because there's 10, like the dots are 10 big and there's 400 width. So here, when I pass run, I'm going to say frame underscore. Yeah, bound to be underscore, right? Frame rate is equal to 6 frames a second. And now we're looking at something at that speed. Yep, okay. So we've done this, the head moves along the direction, we draw a snake, whatever. Now, player control change the direction. One of the limitations of processing P5 in the Raspberry Pi online code editor is that in terms of input, we can only capture, that's the technical term, well actually the browser will capture inputs and then pass them on to, I don't even know how this works, this is magic, frankly, as far as I'm concerned. But the point is that we can't do keyboard controls in this, which is annoying because like there's many more keys than buttons of the mouse. So I could use 2 mouse buttons for like relative left and relative right. That's an option, except that's not how I did it when I kind of prepare this, and I can't remember how to do this. But you could, that's left as an exercise to the reader. So def control. No, actually. So just like we have setup and draw, is it mouse clicked or on mouse clicked? Let's just. Yes, the name is correct. Is this? If I run it and I click, right? Every time I click, it prints yes. So it's mouse clicked. Mouse clicked again, like draw and hello, darling. Sorry, just got a cat. Assault. Like draw and setup, mouse clicked will be called when the mouse is clicked. That's just fairly straightforward. So it's you never call mouse click. This will happen whenever there's an input. So this is an opportunity to check, in particularly the same deal. You will be able to access mouse X and mouse Y as variables that are defined, that are global. Well, they're readable from anywhere. Obviously, you can't write to them, and this is just like the coordinates of the mouse at this point in time. So what I want to do is you click where you want to go. Meaning that, well, let's look at this, right? So if mouse X is smaller than head 0, right? So if the mouse now, no, I'm doing nonsense by direction, right? So if direction is equal, okay, global head, global direction. We're going to change direction when we click, right? So global directions is the one we're writing of. If the direction is equal to the north, yes, so the snake is going up, and you notice I don't have an indentation here. That's because I forgot the colon. When you put the colon, it recognizes it. We know we need one tab in. I say one tab. I mean, couple, whatever. Um, if the direction is north, the snake is moving up, right? So if I'm clicking to the left of the snake, I want to move left. If I click to the right of the snake, I want to move right. So when I'm moving north, like when I'm moving south, I'm only worried about the X of the mouse, right? So if mouse X is smaller than head 0, meaning the mouse to the left, maybe with a comment, to the left of the snake, of the head, we are going to change direction to the left, meaning okay, mouse to the west of the head, then direction. That's why we've got it. Global becomes equal to W for west. Else, well, I'm going to do an elif just in case. Well, no, fine. Direction is equal to east. Whereas if I am going elif direction is equal to, if it's equal to west, let's go counterclockwise again. Then in that case, I worry about the y. So if mouse underscore y is smaller, so okay, so smaller means above, right? So if the snake's going west, oh, this is for me, right? So for you guys, it's gonna be like that. If the snake is going to the left of the screen, then if I click above, that mouse y being smaller, it's above. Then I need to compare it to head 1. Very important, get that right. Then the direction. The direction becomes equal to north. Else the direction becomes equal to south. And then because I've got those two things, I've got the vertical and the horizontal, I can then copy all of this, get back here, put an L and paste it. And so I got it twice, so this is going to become south, but same deal. From south, we either go west or east. We're already going south and we can't go back north. So, and this one is for east. And now if I run this, right, I can make the snake. I forgot something. My snake is infinite. That's because I'm forgetting to do something very important. Is that every time you, before you draw anything, you need to redraw the background. That's how animation works, right? So, and let's do black background again. And now yeah, it's always that letter. I don't know why when I misspell background, which is often, I kind of drop the G. Right, so now I'm kind of clicking, right? It's kind of going above to the left. From here I can go below and I can go right. So which means that when we spawn the apple, we'll be able to click on the apple, it's going to go there straight away. It doesn't have a tail yet, but let's not worry about that. First, I need to eat an apple so I can kind of, nothing. So let's, yeah, the apple spawns randomly, which is great. Def spawn underscore apple. So the apple, we're going to need a draw apple as well. Okay, to spawn the apple, I'm creating a variable onto the global scope, so I need to make the variable global, and the apple, no, global apple. Escape to escape the apple's global, and apple is as the coordinate, so it's equal to. Right, this is where I need to be a bit clever, because although I get 400 wide pixels, the apple needs to be, it's all in kind of slots of 5, 10, right? So the apple can be at 0, at 10, etc. Right? So I need to kind of round it. So they need to do 400 divide size. Yeah, it's like 400 divide by size. Right, if I do randint, yeah. Let's actually make the list in 2 bits, because the list is going to have the same thing twice, essentially, right? So it's going to be a random integer between 0 and 400. This is why I admit I wish I had that in variable, because it feels a bit ugly to I don't know, whatever. 400 divided by size gives me how many, you know, effectively squares of the grid I have on my full canvas. This is going to decide which slot the apple is going to be, and then I need to remultiply this by size. So I know that it's going to be a multiple of 10, essentially, right? And I think maybe the boundary might be a bit messed up, but no, I can work with that. That's actually, I need to be more confident about my stuff. I'm going to teach this for a living, after all. Okay, no apple. That's because I don't have a draw apple, obviously, right? Let's just have a spawn apple uncommented. There's going to need to be a draw snake. I have a draw snake, no draw apple. See, what I don't like about the Raspberry Pi code editor is that they do offer auto-completion, but then to complete it to the first suggestion, it's return and not tab like in every other IDE, which means I keep whatever. That's just my gripe. Again, to draw the apple, this time we're going to take a stroke that is red, but again, I'm going to want like a really bright red, which is going to be hashtag FF0000 for all red, and this will make a point at apple, which I can apple 0. I hope that we're not going to try to access it before it's been defined, but I don't think so, because we spawn the apple in setup, which means every time we draw it, right, we'll be able to line 61. That's not good. Oh yeah, yeah, that's fine. Okay, right. So now I can kind of guide my snake towards the apple. Okay, this is when just get the basics, because that's the simple part. The trickier part is the tail. Oh well, eating/hitting the apple lengthen the snake. Fine. Right, okay. Let's lengthen the snake, but we're going to talk about the tail, right? So we draw the snake. So we've moved. We're going to check collisions here, I think, right? Okay, so check collisions. If the head, so it's only the head that can hit something, right? If the head, and I think I can do just compare it like this. You can compare, although it, in a way it shouldn't, but it's smart enough to do a deep compare and compare elements one by one, because the actual pointer to the memory address of the list is not going to be the same, obviously. But so if the head is equal to the apple, let's just print num for eating an apple. Right, let's just try that. Check collisions. I've added it to draw. We're good. Num. Okay, cool. So what happens there? This is when I need a list. The tail is a list. The tail is a list of position, just like the head is a particular position. The tail is a list of position. Initially empty, I guess, right? And what we are going to do is every time we move, right, we are going to, before we update the head, the coordinates of the head, we're going to add the coordinates, the old coordinates of the head to the tail list. And also we're going to remove the element at the other end, right? So it's tail.append head. Remember this moment, because I will. And because I explain why in a second. So just, and then so we put it at the, put it at the end of the list. So the tail list is going to look like the first element is the tip, and then the closer you get to the end, the closer you get to the head. We add the old coordinates of the head to the back of the list, and then we're going to remove the first element. To remove the first element of a list, we use the method pop. By default, pop will pop the last element, so we want pop 0 to say remove the first element. That will make the snake move. Kind of, like we made the tail. I could show you, but let's see. And what we actually, I'm not going to do this. I'm going to do list head. just so I can demo it for a bit, and which means I can put like any old crap into this, just and that should work quite nicely. Because what matters, this is going to get rid, like within 5 moves, this is going to have moved away and be replaced by actual coordinates. The point is that it's the length of the list that really matters. So I just want something, I need to have good delimiters though. 4 elements, why not? Okay. It means also that probably in this corner we're going to see a little bit of green. So like for the first couple of things, it's going to, well, I'm not even drawing the tail just yet. Oh yeah, so that's the problem, isn't it? Okay, fine. And to draw the tail, where's my draw snake? Yeah, draw a snake. Excuse me. Why is it not keeping the indent? Whatever. For coordinates in tail, right? So we can iterate over the list. For each element of the list, we same stroke, same folks, I suppose. Get it? C this time 0, comma C1, and that should kind of this instance is just less than 21. Yes, well that's a problem obviously if I don't. That's even worse now. Okay, yeah, that's a double problem. Right, cool. And now my snake is kind of turning and working fine. So all I need to do is whenever I eat the apple, I just want to kind of add basically another copy of the head to the tail, which is not going to display until it kind of gets digested, if you see what I mean. So it's only when we kind of move back because we're not this. It's not a new location. Like for a while, there's going to be twice of the same being painted until yeah the head finishes. So it's gonna take a little while to update. But that should, right, if I do tail dot append head, I see I had some viewers briefly, but it's not live that those videos found their audience. Okay, so that didn't, is it my snake longer? Yeah, but of course I need to also redraw and run it in another random location. I feel like it's getting longer, but I'm not super sure. It is, yeah, it started much smaller, right? Okay, so I've got this, but of course I need to spawn the apple. Okay, so the tail moves following the snake. I've kind of done that already, but I'll kind of put it here, maybe like well, whatever. The tail moves following the snake. This was in the that's done by appending, but there's a drawing part. But like what we do is we just append it and pop. So this is actually a data structure known as a queue, right? You kind of enter elements at the back of the queue and you take them off the front. I have a little problem and I can go out of bounds. So we've got two options here. Except I don't know where it's going to be like 0 and 400, right? Look, so that, yeah, it cuts in the middle. Because there's yeah, you know what? I might do, so every time we get like plus size or minus size, I'm going to do modulo 400, meaning that now my snake is going to wrap around. Yeah, obviously. Yeah, if I don't put brackets, we're gonna have a little problem there. No, I can't use a. So subtract, and then if it's more than 400, what this does is that because it's the remainder of the division by 400, modulo also works with negative numbers, right? So if it's like -1, it's going to revert it as like 399, except it's only in tens, right? So it's like -10, it's going to put it back at 390, and if it's 410, or even 400, actually, 400 is going to put it back to 0. Which means I'll never see something displayed at the very edge here, but that's 31. Yes, obviously I can't put brackets always. Yeah, the opening brackets not in the same place. It's just I'm trying to do the streamer thing and keep talking as I code, which I guess is easier to do when you're playing video games than when you're actually coding. Right. Okay. So I'm eating apples. Is it lengthening the snake at all? Okay. You know what? This this was why I've made put this into variable. Right. It's going to be much easier if I do it like this. Oh, actually, it's not impossible. It's not going to be able to because it's bang on at the edge. Yes, I knew I would have an OB1 error, like an off by one error, sort of edge condition. When I did this, that should be excluded. I don't get. Yeah, so okay, so this is y equals 400, right? So it's given a number between size is equal 20, so there's like 50 ways. So it's get put a number between 0 and 50. So yeah, so I guess like what we need here is yes, of course, and this needs to be a divisor of 400. Right, let's try it again. I think 0 should be fine because 0 is 400 in a way, but at least 400 will be avoided, right? So we can eat, and I believe it's getting longer, right? Okay. Right, so at the moment I have a game of Snake where I can only win, which is great. It's not getting longer. It is? Things that if it's getting longer, there should be a moment where like the tip of the tail doesn't move, right? And I'm not. That might happen at the very end once we've kind of digested the apple, so to speak. Yes, right. So it's like there's a little bit of delay in the snake growing, but it does grow. It actually is going to grow after a delay of. This is annoying. Oh man, how am I going to? Okay, I guess I can't. I can't kind of like I thought it wouldn't be much of a problem. The problem is that the longer the snake grows, the longer it's going to take to actually grow, right? Because now I got to go through my double head needs to go through the whole snake before it kind of actually becomes a segment that will be drawn at a separate location, making the snake visually larger, if not kind of in the memory. Okay, but let's just like, right, fine, whatever, for now. Um, I guess that solving this is left as an exercise to the reader. Very good. Okay, now let's make this a little bit elif. I think that yeah, I don't want if the apple spawns over the snake and if I manage to go over it sideways, I think that's a win. There are complicated reasons why I don't want to kind of yeah, and if um now this is where it's going to be interesting, right? What I want is like so this is the fail condition, right? So like okay, the collisions we're checking is like touching the apple, and this is like touching the tail. I mean, could I just do like head in tail? Um, let's just do like text game over. Actually, let's do text underscore size. 40 sounds like a good weight, and I'm going to display this at like what, like in the middle. So okay, 50, maybe like maybe 100 and 200. Okay, is this doing anything? So I'm not long. I'm thinking I'm not long enough to die. I would have to try very hard, but. Mhm. Ah, no. Okay, so that's not quite working. Right. So. that's fine. I can do if. You know what? Elif, else, actually let's do an else. Let's put an else in there, right? So else, otherwise we're gonna check it by, I can refactor it to something like more Pythonic in a minute, but it's just meant to be GCSE, so let's keep it simple. So I'm just gonna want to iterate over each coordinates in the tail, and then if head is equal to tail, then let's call it game over. It's good to have it in a kind of like function. So game over will. I can't set the frame rate to 0 here. I'm just so it was like text size, was it 40? Text weight, text size, and then put the text. The first one is the text we want to display. Let's capitalize it differently. No, I want it all caps because it's an old arcade game retro. 100, 200. Okay, so game over. There's going to get game over in a little function. I can then put checks if I don't want it to wrap around because make it a little bit less easy. Uh, okay, like I feel like it's not working. Oh, not head equal tail, head equal C, obviously, right? Okay, I need it to be a bit longer to be able to eat its own tail. Tail. Huh. Hmm. Hmm. Nope, I was able to get through it. Okay. No. Okay, so it's not working. So if head equal. So this one works, but this one doesn't? Is it because I append them with list? Let's just just gonna put a little bit of logging so I can see what's going on. All right, so yeah, those are lists. Yeah, as I expect, right? They can have by there's a gap of there's a gap of 20, yes, because I put size equal 20, right? So they all divided, kind of aside apart by 20 pixels, which that's kind of fair enough. No, not to worry. I can simply do like head, just compare them element by element. So I want head 0, head 1 being equal to C0, C1. No, you can't. We can't do comparisons like that. Whereas I'm sure if I put them, yeah, okay. If I actually define a tuple with them, surely, because you can do assignment by two variables, right? Which is quite cool because you can do a b equal ba rather than use a temp variable as they teach you in class. Okay, it was working yesterday. I'm gonna have to open the one I did just to figure out what's the difference. Oh no, maybe okay. Let's just actually. I need to have this here. So this is going to wait for. I'm not. Normally I would store a variable with the whatever was input, but this is to wait for the player input. And as we found that probably even forever. But okay, collide. Yes, right. Oh, except the last thing it drew was the apple, so I can put it in. I don't know. For well, maybe. Now this is where if you were running this in in P5 Python natively, you would be in your console, press return, and you'll be able to have another game. Except here we can't. The only way to stop it is to kind of stop and run it again. So after much of that, well, let's try if I can just do the head equal C. None of get correctly stop the game upon game over. Yeah, right. That's why my kind of clicking to in circles. I don't know how long there. Let's have it in the like boom, big bright green 00 FF 00. Okay. Okay, it's looking pretty good. So what do I have now? Right. Keep track of the score. So da da da. Score is equal to 0, and every draw. I'm gonna put in. Can I put in draw loop? No, let's put it in between because that way we'll reuse the green. I just put it in plain text. I could, literally cannot be bothered. Text score, and let's put it at. I guess 0.20. I don't know. I think it's the bottom left. Okay, maybe actually that's the weight of the. That's a bit much. Still a bit much. Yeah, if I don't if I don't increment the score, okay. This is a string concatenation in line in my function, right? And of course, I need to every time I touch the apple, I need to. So I do need to make that a global to change it. Global score, and we're just going to say score plus equal 1. Yes, of course. We'll have not. What am I doing? We cast it to a string because score is an integer. So if we do string concatenation, we need to concatenate two strings to make a string. Therefore, I need to cough. I'm just going to mute for a second. Chunky. Okay, we're back on track. Right. What is going on here? Do you know what? Like, maybe I just don't put any text size. Maybe I don't really understand how it works quite well enough. The stroke weight. Yeah, okay. You know what? So I'm just going to put it at the very bottom. So the stroke weight affect the the text. Yeah, okay. Stroke weight 1 and then text score colon space plus str of score, and I'm going to display this. This corner looks pretty good, right? So there was like 0, maybe not even 20, maybe half that. Oh yeah, because that would make sense if like the font. Yeah, of course. That's why I was doing it after the apple. So yeah, let's use some blue. Why not? 0, 0, 0. 4 zeros, 2 Fs. Boom. Well, this is surprisingly annoying. Okay, I should have. This is that was freestyling this one. So P5 Python reference. Yeah. Okay, we had it here. When I yeah, okay text. Just too manly to read the manual. So like Python just English, right? Just go and I like a Leroy Jenkins. Text align, text ascend, text descend, text font, text leading, text size, text underscore size. Yes. I can get on board with this one. And strings and drawing text. Displaying text. I need to define a whole bunch of text font, just like text align, text. Oh, and that's like a coordinate passed as a tuple, which actually that would work quite nicely for using tuple. We can refactor it with tuple in a second because I'm nearing the hour, aren't I? 50 minutes in, right? So that's the problem. Is it? Because the only thing that's drawing is okay. So of course I do need to put stroke weight size back in here. That may have been the problem actually. Yes, all right. Except I don't see the not seeing any score now. Oh yeah, that's because I've commented it out. Right. So the problem is that was not the text was fine. It's just that put like maybe we can't see it in. How about some Sion? Ah, hello. Ah, there's the fill. There's a whole thing now. Right. Okay. Fine. So the text is also a shape that gets a stroke in its fill. So it's kind of word out. Fill it with bees. No, with blue. Yay! Okay, so that was green, but we can just quick. Okay, blue. I am blue. Actually, let's have it green. No, let's have it the same color as the stroke, which is this kind of cyan, slightly. Yeah. Okay. Why not? Whatever. You adapt. The critical thing is now when I eat an apple. Yes. Right. Score one. Okay, and I think we pretty much have a game, except it's very hard to lose. So, in order to make it harder, now I've got a game over. Instead of doing this thing here, which, I'm just going to keep the brackets, but I'm going to Command D this and backspace it. Boom, it's gone. And then here, if uh, larger than 400 or yeah, I couldn't put them on one. Yeah, if I kind of tab them. So if the head is at I should have them in different order, but whatever. And then like this again. Except this one is this time it's head one. Then game over. So now the walls are harmful. Yes, I don't doubt this. Do we need like some brackets or something? Is that the problem? If I just do this, it's going to interrupt that expression. Yeah, that's fair enough. But still, no. Oh yes, that's because I've got. Oh yeah, put them in and it put the closey bracket at the same time. That's fair enough. Okay, so I hit the wall. Game over. Yeah. Right. Quick one. How can we make this better? Right. Here, initially, I had done this, which you'd think would make sense. I just put the head into the tail, just like we can compare, like it compares the element. When you say I said those two lists equal, I don't mean like the pointer in memory is the same. Just the elements are equal. It understands that. But if I actually had this, it's going to add not a copy of head. It's going to add a pointer to head, meaning that in that instance, my snake's not going to grow, or maybe it does. Yeah, because actually I'm using kind of comparisons there, so that's probably not the. No, the other thing I wanted to, you could probably refactor that as a tuple with, I think, because we're redefining it, but then we would have to redefine it as a tuple there as well with brackets. The reason I'm thinking that is as a tuple, we'll be able to pass it straight to point. It's not a massive improvement. What I would like to change is this guy, right? So what we want to check is that any of those, like the coordinate, the head matches by value, not by reference, um, matches any of the coordinates in the tail, right? So else we can say any. Okay, just check this out. Let me have this moment. Okay, it's any will evaluate a list of booleans, and then if any of those is true, then it's like a kind of global OR, right? Kind of a list-wise OR. You also have all, which is a list-wise AND. It's like all of them are true. So, and then you need to build a list of boolean. We're going to build a list of boolean by booleans plural by list comprehension. A list comprehension, that's a term that comes from maths actually, when you define things by comprehension rather by enumeration. It's like you kind of define it in the abstract, by abstraction, whatever. So in that instance, I'm going to say head equal C for C in tail. So putting the for, you can basically build a list. If I can spell, I need to spell head right? You can build a list. If instead of building a for, you can build a list with the for straight in the list, right? So this could be, you define an iterator that's going to take all of the values in your list, and then you build an expression involving it here. So that could be passing it to a function. That could be, in that instance, I'm kind of using a Boolean operator to see if it's equal. So that's going to give me a big list of the length of tail with hopefully false, 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 unless I hit one of them, where it's going to be a true, and the any means like if any of them is true, then I return true, meaning I can do elif this colon, and then, okay, I'm not getting rid of much. Still, these compressions are pretty cool. I like them. There's plenty of ways of improving this game. I wish if I had keep track of the score, I've done this. It's not there though. Well, I guess like I'm just gonna put it back to the I don't know if the comments were more like my steps in my process. So what have I done? I have a snake. It moves on its own. When I click it, it changes direction. Because I'm using the mouse. You know what? Let's use the mouse buttons. Why not? All right. P5 processing. I'm going to need to do chapters for this video, so that's daft because I'm not. But more work for me at the end. P5 processing mouse buttons. Well, no, P5 processing. We know P5 processing with mouse buttons, but like Python. Oh well, hold on. I've got the documentation here. Mouse. So mouse. If it clicks a little rodent. Interactivity. Yeah. Mouse press. Mouse signal. No raise brightness data, easing loop examples, output P5 for processing user pointed list. All right, I'm getting sidetracked here. Input, mouse press, key pressed, mouse, hello, mouse pressed, mouse clicked. When the mouse has been clicked, and then do I have a mouse, X mouse Y? Mouse button, yeah. Ah. Okay, so I might need to do like on mouse pressed, because once the mouse is clicked, I probably won't know which button is being used. Let's try it. I'm not making any promises. I wish I could. Can I just like... Let's have a... yeah. Old school. I could make copies of things in there, but I'm just going to take that, go there, and then like paste it in here just before I mess it up completely, because that's my jam. All right, so I wanted to go... Can I just collapse the stuff? Yes, excellent. Right, so this is where we're going to intervene. Here I'm going to go mouse pressed. And say mouse underscore button, left or right. Yeah, in capitals. Can it be that simple? Often with processing and Python in general, it is that simple. So when we're north, left Texas east, left Texas west, right Texas east. Um, and when we are west, it's left again that takes us north, and then right button takes us south. Don't know if this is going to be easier to control, but of course not actually, because at the moment I can just click on the apple and spam click and then I'm fine. So, and then I've got this, right? Same deal, right? I've got the vertical, I've got the horizontal. I'm just going to take it right here and then just go take all of those, remove them and paste the new one, except now I'm doing south and east, but it's the same principle. Let's see if that works. Mouse underscore button is not defined. I've had this problem, so that's P5. Yeah, okay. So I'm glad I've made a backup. Right. Well, on this underwhelming note, let's see. Let's kind of do a quick. Let me do a fade to this camera. Yeah. All right. I'll get some kid doing it again. Oh, to this camera, and then to this camera. Yeah. Okay. What did we learn? We have made a little game of Snake. We have learned a little bit accidentally about the difference between passing by value and passing by reference. But there's the one that kind of tripped me up when I was rehearsing this yesterday. We have unwittingly used a queue data structure where we enqueue and dequeue the head into the tail to display essentially where the head used to be is where the tail is until there is no more tail. So that all we need to control is when we kind of eat something is just adding the head to the tail. To be fair, we could actually add anything because at the moment there's going to be, that means that right after we've added it, there's going to be two heads in the tail. They're not going to be displayed as distinct segments. It's only once those have been kind of come out all of the other end, then the snake is finally going to get longer, which is more and more noticeable the more and more you play the game. But you know, in about 100 lines of this code, I've got this. But I will now go and try to. Sorry, I need to. So I don't do. If I can't work OBS, well, of course, it's not working now. Yeah, all right, now it's working. Yes, I will now go and play the daily challenge of this to see. I have lost the daily challenge, like the Super Snake, where then there was like 5 of them and they were moving and what nonsense. All right, well, let me just this camera now. Yes. Um, Thank you for watching. Not that many have live, certainly, but hopefully this will find its audience later on. And I hope to be able to find the time and also the ideal appropriate projects. I want to rip something from the internet. I want something I want to go, like, I'm going to design myself and make myself to be able to do more of those in the future. Hopefully, maybe with some object-oriented programming, because I think it seems my viewership to the degree I have one is much more about A-level stuff or A-level aptitude, certainly. Anyway, love you. See you soon. Like and subscribe. Send it to your friends. Do the things. Comment. I don't care. Just like